Greetings and welcome. There we are, friends. How are you doing? You snuck up on me. Today we're learning about complex fractions. You've actually already seen some stuff with complex fractions, right? We talked about, you might recall, complex fractions in the form of a stack-o-frac situation, right? I don't know if you guys remember.
Like flapjacks.
Let's see, where's... All right, here we are. So stack-o-frac was kind of like one of these. Actually, speaking of flapjacks, I did make some nice, awesome pancakes today, or yesterday. I made them twice this week. Delicioso. So that was a stack-o-frac, and you might recall that you'd multiply by the reciprocal of the denominator in order to do that, right? So that is, here we are. So we refer to this as stack-o-frac, right?
Stack-o-frac.
And then the other situation we had was the sums or diffs of fracs in fracs. All right, and that situation would look something to this effect, where I'd have a fraction like subtracting a fraction all over another fraction, or sum or difference of fractions. So it could look like that. Could look like this. All right. So the reason I'm kind of trying to show you these general layouts is so that you have a better degree of recognition. You could kind of spot these a little easier, know what technique to use. And I want to point out, technically, you could even have something like, you know, like a third fraction or something down there. You know, all sorts of craziness. All right, so, whoa, too far. There we are. So we're going to specifically talk about these sum and diff-o-fracs today. Don't quite have the same roll-off-the-tongue name as the other one does. So we'll start off real easy. What if I had the following? What if I had 1/2 minus 2/3 all divided by, that's right, 1/6 plus 3/4. So when doing this, well, I mean, you could kind of view it as like two separate problems where you could figure out how are you going to combine the ones up top and how you're going to combine the ones on the bottom. So let's try that way first, right? So what I would have to do is, well, if I'm going to combine the ones on the top, we would have to find the LCD of its denominators, right? So what's the LCD of the numerator's denominators? 2 and 3 is 6, right? So I'd multiply this one by 2 over 2, and this one by 3 over 3. And what is the LCD of the denominator's denominators? Them they are double denoms.
12.
12, right? So what do I have to multiply this one by? 3/3. And this one by 2/2. Mm-hmm.
What happens if you like put in like 24?
For the, well, you would get a common denominator. It just wouldn't be the least common denominator, and then you'd multiply it out, and then you'd just have to simplify again later. So having the LCD is valuable. It actually saves us more work in the long run. So let's figure this out. So 3/3 times 1/2 is going to be 3/6 minus 2/3 times 2/2 is going to be 4/6 all over 2/12 plus my mistake 9/12. Okay. So now that I've got those with common denominators, I can just kind of combine them. So let's see. Actually, I'll keep working down this way. Why not? So 3/6 minus 4/6 is what? Negative 1/6. I agree. Divided by, let's see, 2/12 plus 9/12 is 11/12. And I just want to point out this is a, whoa, that was weird. This is a mondo fraction with two fractions inside it. That actually fits a stack-o-frac situation, doesn't it? So what do I do with a stack-o-frac? Multiply by the reciprocal. Ain't that right, Jacob?
Dang straight.
So, and to do that, notice 6 and 12 can cross cancel. 6 goes into 6 once and into 12 twice. And I think that's all the canceling I can do. So I'm going to have negative 2 elevenths, I believe is my answer. Fully simplified, blah, blah, blah. So, well, I mean, that was just kind of like a PEMDAS-ish approach where I was just like, all right, I've got some fractions in the numerator that I could have combined, some fractions in the denominator that I got to combine, and that's how I did it. What's your question?
Why is there 12 11s on the top?
Well, I multiplied by the reciprocal of this guy,
Which is
right? So that's why I had to do that. So that's one way you could do it. Now there is another way. Let's see, would I have enough room to fit it in here? I wonder. I might. No, I'll do it down bottom. What's this? 1/2 minus 2/3.
Wait, what was the answer to that again?
I don't remember. What was it? Negative 2 elevenths. So let's do the same problem using way number 2. All right, which this way is way cooler, if I might say so myself.
I like way number 1 a lot. So.
Well, this one's actually going to save us time and space. It's going to be good. 1/2 minus 2/3 all over 1/6 plus 3/4. And what I'm going to do this time is step 1 is find the LCD of the, ready, wait for it, denominators. Okay? Emphasis on mini. All right, so instead of finding 2 separate LCDs, I'm actually going to instead target all of them. What is the LCD between 2, 3, 6, and 4? What do all of those go into? It is 12, I think, right? Yeah. So, in analyzing that, the LCD of the denominators is 12. For all of them. So 2, 3, 6, and 4 all go into 12. All right, step 2 is mult top and bottom. Of, I guess I'll call it the jumbo frac by LCD over LCD. All right, so let's do this. So I'm going to multiply top and bottom, and sometimes I'll let you actually literally just write the shortcut of LCD over LCD. In this case, let's actually write it out until we get familiar with this process. 12 twelfths. So jumbo frac is being multiplied by 12 twelfths. All right, notice it also was not the part of the LCD it was missing. I was just straight up multiplying top and bottom by the LCD. All right. So let's actually multiply this out. Now, in doing so, this whole numerator is going to be multiplied by 12. And in doing so, this whole denominator is going to be multiplied by 12. All right. So let's see what happens when I get this. So equals. Now, I like to try to be clever. Let's see, 12 times 1/2. You could write that as 12 halves, but let's not waste our time. Because this 12 is actually, I know this 12 is going to cancel out with each one of those denominators. So let's do the division before the multiplication. All right, so let's do 12, what should we do? 12 divided by 2 is what?
6.
Let's see. Where are we? Here we are, here we are. So 12 divided by 2 is 6, and 6 times 1 is 6. So I get 6. I like it. 12 divided by negative 3
Negative 4.
is negative 4 multiplied by 2.
8. Negative 8.
Then it'd still be negative, yep. So notice I've killed the fractions up top. Not unlike our techniques of fractionicide from back in the day, mind you. Let's see, 12 divided by 6 down here
2.
is 2, and 2 times 1 is
2.
2, okay. And 12 divided by 4,
48.
3 times positive 3 is 9. And now notice I can just kind of like combine these. 6 minus 8 is negative 2. 2 plus 9 is 11. And I think we've seen that before. So, what was your question?
But I feel like way number one still.
Well, way number 1 is going to be even more cumbersome when we have our rational expressions and not just plain old rational numbers. So I definitely recommend using this technique. I mean, would I mark this wrong if you did way number 1? No, I would just pity you. I'd feel bad that you spent so much time. So bad. So let's use this technique on an actual rational expression problem. Let's see. Looks like I'm almost out of space at the bottom. I'll just do this one up top on the next side here. So here we go. So example A. Let's say I've got x over 2 minus 5 all over 6 plus 3 over x. So looking at this, you might not be able to spot the denominators right away. What is the denominator of 5? 1, right? And the denominator of 6 is 1. So if I want to find the LCD of the denominators, let's see. It needs to have 2, 1, 1, and x have to all go into it.
I don't know how a letter goes into a number.
2x. Think about what would cancel out with all of those denominators. Man, I just said that really messed up that time. Right, well, 2 would cancel out with 2x, 1 would cancel out with 2x, technically, and x would cancel out with 2x. So if you're not a fan of the variables, you could just start with the numbers and then throw your variables or expressions in later.
Oh, wait, I don't understand how you got that.
I found the LCD of all of the denominators.
How do you know it's 2x?
Yeah.
Because 2 goes into 2x and x goes into 2x.
So what about 1?
1 goes into everything. So we're even better on that. So let's multiply top and bottom by the LCD, 2x over 2x. All right, and I'm multiplying the jumbo frac by that. All right, let's see, where's my, man, keep losing my mouse today. Oh, good, here comes a cloud so I can see my screen a little better. Bam, bam. So Hank, we're going to distribute this to top and bottom because of those vinculums there. Fraction bar is a type of grouping symbol. So let's see, 2x times x over 2, tell you what, let's think about it this way. 2x divided by 2, what would I get? X, and x times x up top is
1.
X squared.
Or 1, right?
No. 2x divided by 1, well that's still 2x, and 2x times negative 5 is going to be negative 10x. And notice I've killed the fractions within the numerator. Alright, let's see, down bottom, 2x cancels out with 1, it don't, and 2x times 6 is 12x. And 2x cancels out with x to be what?
X.
No.
X squared.
1/6 x. 1.
No. X divided by x is what?
1x.
1, and then I've got that 2, so that's going to be 2. And 2 times 3 is?
4.
Hank, I don't think you're even trying anymore. 6. There we go. So, now I've gotten rid of all of the mini fracs, so now I can just simplify this like a normal problem, which of course means I'm going to factor it if possible. Let's see, there's my mouse. So I'm going to factor out, here this is a GCF problem, factor out an x. Here this is also a GCF problem, I could factor out a 6. This is going to equal x times x minus 10 over 6 times x plus 1. And can anything cancel out here?
2x plus 1. Yeah, 2x.
Oh, my bad. Good save, 2x plus 1. Whew. Anything cancel out? No. So this one's completely simplified. All right, so the idea for dealing with these sums or diffs of fracs in fracs is we just going to multiply top and bottom by the LCD of the denominator. All right, so these were all monomials. Let's see if we can get this a little bit crazier. Last example for today. Here we go. Are you feeling crazy, guys? I'm feeling crazy. Here we go. 1 over 2x squared minus 2. All over. So far this is looking like it could have been a stack-o-frac, but it ain't. Here we go. All over 2 over x plus 1 plus x over x squared minus 2x minus 3.
This is the last example.
You got it, dude.
Michelle Taylor.
So, exactly. So I'm going to have to find the LCD of all of these denominators. First thing I might want to do is factor them, right? So that way I can actually determine what the LCD is. So 1 over, for this one I could factor out a 2. Oh man, that's going to be 2 times x squared minus 1. This one's already factored. Plus an x over, what is this factor to be? Well, I can find the factors of 3 that subtract 2. So that's going to be an x with a 1 and x with a 3. Right. And what are their signs going to be?
-3 plus 1.
I like it, because they got to combine to be -2, so the more influential one must have been more negative. Now, I see one more thing I could do.
Multiply the x plus 1 times 6.
That's
Yeah, I've got something that's even further
So
factorable.
that'd be x minus 1 all
Let's see. So that's 1 over 2 times, no, wrong pattern, x plus 1, x minus 1. That's what difference of squares factors to be. This is an ugly vinculum, but that's okay. Once there was an ugly vinculum. It was so ugly that everybody died.
Is that a book?
No. I was semi-quoting Patrick Starr.
Oh my gosh.
I don't know why I don't have more SpongeBob quotes at the bottom of my quizzes. It's a shame. So, okay, so I did all of that work factoring my denominators for what benefit? I want to find the LCD of all my denominators. So what is the LCD of this, this, and this? Whew. All right, well, I'll tell you what. I know that 2 has to go into it. Okay, 2 goes into it. I know x plus 1 has to go into it. How many x plus 1s do I need?
1.
Just one of them, because there's only at most one of them in a single fraction's denominator. I know x minus 1's got to be there.
Oh, this is going to be a long one.
Yeah. And I know x minus 3's got to be there. Whew. Okay. Whew. Barely fit that. So now what am I going to do?
How are we supposed to do that? How are we supposed to
When are we ever going to use this in real life?
Don't worry about it.
Every day.
On the test.
So now
So,
we have to multiply the plus x plus 1 on one side.
I got to multiply top and bottom by the LCD in the jumbo frac sense.
Or x minus 1 on one side.
And I'll show you what cancels out. This is going to work out just fine. So jumbo frac, jumbo frac. All right. So, all right, here we go, here we go. This is going to be good. Because technically the LCD should kill all of the denominators, or denominators specifically. So let's see, if I multiply this LCD by this fraction up top, remember the LCD is this whole thing, what cancels out with the 2?
2.
The 2. What cancels out with x plus 1? The x plus 1. What cancels out with the x minus 1? The x minus 1. What am I left with?
X minus 3.
X minus 3. And what is x minus 3 times 1?
X.
Minus 3.
It's going to be x minus 3 in my numerator. All right, down bottom. What's going to cancel out?
X plus 1.
The x plus 1s. What am I going to be left with?
X minus
2 times x minus 1 and x minus 3. And they're all being multiplied by this 2.
So 4x minus 1, x minus 3.
Okay, yep. Plus And let's see, for the second fraction, I've got the LCD being multiplied by this. What cancels out? An x plus 1 and an x minus 3. I'm left with 2 times x minus 1, and I'm multiplying that by x. So that's going to be 2x times x minus 1. Because this one just had the 2 and the x minus 1. There will be an x squared in there eventually once I simplify that all out. So, okay. Now, the benefit of this was I've killed all my mini fracs. And now let's see if I can simplify this. In order to simplify this denominator, I'm actually going to have to, unfortunately, multiply that all out. So x minus 3 over, let's see, that's going to be 4 times x squared minus 4x plus 3, I believe. Plus, if I distribute this is going to be 2x squared minus 2x. Man, it's a good thing we're awesome with polynomials these days. X minus 3 over. Here we go. I can distribute this 4 to all of its buddies. So that's 4x squared minus 16x plus 12 plus 2x squared minus 2x. All right. One big frac. And I think I can combine some like terms in the denominator. Hope so, hope so. Oh, what do you need? You got it, dude. Let's see, here we are. So combine 4x squared and 2x squared. I'll be able to combine negative 16x and negative 2x. And negative 12 will just be hanging out. So let's see, my numerator, I'll have x minus 3 still. My denominator, I'll have 6x squared. Negative 16x and negative 2x is negative 18x. And plus 12. Oh, I can factor something out of that. Now that I've got it combined. Oh dear. Oh dear. And it's very difficult seeing my, oh, I selected black. That would do it. My poor mouse. So hard to see today. How do you guys factor this? 6 out of it. I like it.
So x squared.
X squared minus 3x plus 4.
2.
Plus 2.
Plus 2, that's even better, thank you. Okay, and can I factor this?
Yeah.
Factors of 2 that add to 3, I think the only ones, yeah. X minus 3 over 6 times x with a 1 times x with a 2. Negative, negative. I agree, because they got to multiply to be positive. They add to be negative, so I think that works out. And nothing cancels, but I have simplified my problem. Okay, so this one would be difficult to do if we had tried to combine these ones in the bottom first. It would have been a little bit more work, maybe. Well, yeah. Sure. And so that's the general idea, friends. We find the LCD of the denominators, multiply top and bottom of the jumbo frac by that, cancel everything out, kills all the little fracs, and then you just simplify normal life. So thanks for watching, Internet friends. Bye-bye.